Rosebud Continuum Eco Science Center, and we're experimenting with Solar City's handmade solar hot water system. This one only has one solar panel of the two that we're preparing, and when Jeff and Liz come from the East Coast to work and we finish up the second panel, we'll have twice the amount of sunlight turned into heat for this barrel here. But what we did find in our testing is that a single panel heats up this half of the tank to about where this valve is, to about 110 degrees Fahrenheit. Does it pretty reliably on a full sunny day, but only half of the tank, and then this half of the tank remains dead cold. That's a single day of full sunshine here it's now April 13th, and so this has been going on since the beginning of April. So in the summer it might get to be even more, but that's been the average. It's 87 degrees Fahrenheit outside right now, ambient, but we've let this sit in the sun for 2 days now, and the question is, does 2 days on a single panel give you twice the amount of hot water? Does it fill the whole barrel with 110 Fahrenheit water, or thereabouts, 107 to 110? Or does it just fill the top because it's going in at this mid-level? Does it just heat this up more? So we're going to see if there's a thermocline when we get past this middle section here. It's insulated at the top, and when I open up the unsealed barrel, I already feel the heat. Wow. So I put it in the very top, and it is 123 Fahrenheit, so 124. That's pretty darn hot. 123, 124, yep, right there. So I'm going to plunge my hand in and see how far down that gets. It's going to hurt a little bit. Ow, it is hot. Oh my gosh. All the way to the bottom. And it's like, ow, get my hand all the way to the bottom. At the bottom of the tank, it is 96, 95. Down there, 96. So it did heat the entire thing up past 87. But if I bring it to about 2/3 of the way, ow, it's still 110 or so down about here, and about 105 here, and then it gets down to about 90. What did we see? 96 or so down at the bottom. So the answer is a little bit of both. The 2 days of sunshine with a single panel is getting 124 all the way, ouch, 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 120 up to the first half. Ooh, that hurts. Boy, is that hot. That's going to be good for the baby's diapers, because we're doing this for the cloth diapers. That's why we're doing this, because we use cloth diapers, because we ain't going to put plastic in any landfill, and we have a lot of diapers to wash. So 124 to 120 up here, then you get down into the sort of 110 range down here, and down onto the 90s down there. Whereas it's now 82 out down in this region down here, and 80. So
nice.
It definitely works. So if we only do the laundry every 2 days or 3 days, we're accumulating a lot of heat that can be used, because 110 Fahrenheit, let's face it, really isn't enough for some of those diapers to get some of that mess out of the diaper in terms of the color stains and stuff. So we're really pleased that a single panel can get up that hot, and this is probably enough water to do a load of laundry, but we're actually getting hot water down here as well. Now, when we have that second panel,
so the other kind, the second half is maybe good for a shower.
Yeah, sure. Yeah, the second would be great for a shower. Anything over 97, which is 80, 89.7.
98,
89 is
98.
body temperature. So 94, 95, 96, 98. All this is going to be great for a hot shower. This is great for doing the laundry. But wow, it's going to be great when we get that second panel in there, because we'll get this kind of performance in 1 day rather than over 2.
What do you think the impact of a second panel?
It'll be that we'll get the same result in 1 day rather than 2 with the second panel. And if for 2 days, if we don't use it, who knows how high this could get. It could get up to maybe 140. There's going to be a limit. Usually the limit, it used to get up to 50 Celsius in Egypt, and 50 Celsius is multiplied by 2, you get 100, remove 10%, you get 90, and then add 32, so that's 122. Well, this is about the temperature. This is 50 Celsius up here. So that's probably the max that you're going to see on a single day, but it might accumulate. We don't know. That's why we have the data measuring. But this is really a good result. The last thing to check today is if I open this up and drain it down. So this is if we were using it. You can see here very clearly it's at 122. coming out of down at this lower level. Now I do have the ability to put cold water into the bottom so that we can use some of this up, but it probably will mix with it. We do know that as this hot water falls down by gravity to this level, that 124 degree, see 123 is coming here, that hot level up here is going to come down and come out at 124 to go into the washing machine. But then when it gets down to here, it's going to stop. So I have to add cold water at the bottom to push the hot water that's here up and out. And usually you only do that after you've completely drained this part of it. If otherwise, you'll be adding cold water that'll start mixing, create turbulence, and you won't get that full 122. Let's see that. So I'm going to turn on the water. Oh, the water is on. Okay. So what's going to happen is, what's going to happen is the toilet float that's in here, there's a float valve. As the water level gets down lower, the float valve is going to go down, letting cold water into a pipe that goes down, starts at the top where the float valve is, goes down to the bottom, and then adds the cold water up. I should insulate that pipe because there also cold is being transmitted, or rather sucking heat out as the cold water goes down the pipe. But so far as you can see, ooh, you want to touch that? That's pretty nice. That's going to be what you're going to be doing the baby's. That's hot, right? You can't really keep your hand on that for very long. No, it's that's too hot. That's going to be great for doing the diapers, right?
Yeah.
Yep. So, very promising result here. And generally, you can keep this running at this trickle rate for about 12 minutes. Even if I open it up a little more, it's a much larger rate. Generally, you get about 12 minutes at this rate from our experiments. And if 12 minutes of that, that's a good shower if you were taking a shower. You know, certainly 2 people could do that. And that's from 1 day's sunlight. But that's usually at 110. 2 days gives us this 123. So, pretty darn hot. And I'm just going to keep this going just to see when the temperature drops down. I think it's very promising. And so don't be discouraged if you can't do 2 solar panels, but you've got 2 days of sunshine, you can get nice piping hot water.
We
But
don't really wash diapers every day, so that's...
how often do we wash the diapers?
So now at his age, 10 months, we wash once a week.
Once a week.
Collect them. I have enough time. I collect them in a
Oh.
wet bag or in a bucket, so the poopy diaper, which is not too poopy diaper, like, because he's even poop now is too solid to, if you're able to drop it in the toilet because it's a cloth diaper, it just doesn't stick to it. And then whatever left on the diaper, from the poop, we put it in a bucket with water. So when we wash it, it doesn't really need much of a detergent or something. And yeah, once a week is enough.
So once a week. So I think
But sometimes twice, but like maximum twice a week.
it just went from 122 down to 121 because the cold water is going in. Normally you would never see this temperature go down because the hottest water is at the top, and if you didn't have cold water coming in and replacing the water that's lost, this would rise up to whatever the topmost temperature was. So since it was 124 at the top, it would go 122, 122, 123, and then 124. What you're seeing now, this drop in temperature, is showing you that we are getting to the point where the float valve went down, letting cold water in, and the cold water is mixing with the hot, and that's why we're seeing a temperature drop. And I can easily demonstrate that in a few more seconds, because what I'll do is I'll turn off the cold water and you'll see this figure actually rise, even though there isn't any heat gain coming in because the sun is behind the trees. So without any heat gain, there's no way for this number to go up, but there is still 124 degree hot water at the very top that's been moving down. and it's sitting there above the area where the water's coming out. So now we've dropped to 119. That's still super hot, so I'm not going to remove it now. I want to see how long this this gets to the point where we would stop wanting to use it, and then I will turn off the cold water, and you will see that we can get back up to 123, 124. But right now it's still piping hot, and if I have to let this go for 20 minutes, I think I will. We'll see how long it lasts. The last time, I think the longest I got it running before I turned on the cold water, just to drain that amount of hot water, was 15 minutes at this flow rate. So certainly it's a lot of heat. And of course, you can use this to heat up your biodigester. For those of you who are contemplating building biodigesters, you can use this hot water to get more performance, so you're not losing that heat. Yeah, I'm still doing some science here. Science. Now it's dropped to 118. Anything over 110, and it's certainly good. Even more. I mean, anything really. I mean, for the diapers, 110 and above. For showering, easily, you know, 97 and above. Anything. I mean, 97 is 10 degrees over body temperature, so it would feel nice and warm. Okay, so we're getting a drop now. It's dropping fairly quickly as more cold water comes in, and that's because the big float valve in there is, you know, is dropping lower and opening up and letting more cold water go in, which is creating turbulence and leading to that mixing. But still super hot. 118, it just danced between 118 and 117. Now it kind of went up, now it kind of went down. And we're at the 12-minute mark, but not 12 minutes since I started flowing. So probably been going about 8 minutes of flow. It's gone up to 118. So while we're waiting and doing this timing experiment, what more can I tell you? The more you insulate the barrel, of course, the more heat you retain overnight. And so you then get this additive effect each sunny day. If my pipes themselves were insulated, I wouldn't get any losses for the hot water coming up. The cold water going down technically doesn't need any insulation, but if you did insulate it, you certainly wouldn't lose anything. These are always dead cold though, because this is sort of the cold area down here. However, there reaches a point when you get what they call thermal stagnation. If the water coming out is the same temperature as the panel, then hot water is not going to rise. It'll just stagnate. The whole system will stop. You need to think of hot water like bubbles, and bubbles always rise. That's why if you have any areas where this pipe goes down, then you won't get any hot water thermosiphoning through. Oh, it dropped to 115 just now. That went up to 116. Still plenty warm, 115 now. And a few more degrees to go. We're going to replace this, by the way, with a rigid pipe. And instead of circulating all the way around the back of this, which we had to do to keep this on an upslope, as you can see, that black hose was too long and we couldn't cut it. So to keep it rising up, we had it go into the barrel back here. But when we finish the system, that's where the hot water is going to come out rather than the hot water going in. And I'm going to take this and have a very short run from here directly to here. That is going to be on with a rigid pipe and much shorter and insulated, so that we get that direct transfer of hot water, and that's going to help improve the efficiency of the system. It is now at 113 as we come in here. Now this is never going to stop now because I have the cold water going in. So it's really about when do I want to shut off the cold water. Now it's gone to 112. But my suspicion is that we will not turn on the cold water until after we're done using all of the hot water up there. That's the next test to do, is to run it down till all the hot water that's on the top of the valve is done. Then push the cold water in and see if we get any good hot water coming out from the bottom. That's another experiment to do. Now we're at 111. That is close to the top temperature that we used to get from one day of sunlight on this single panel. That's the temperature we're at right now. So definitely letting it sit for 2 days has been advantageous. We're now got to 110, and so that's the point where I guess we've now probably used up that half of it, because we're now at 16 minutes. Well, yeah, roughly this is about the point where we've used up that entire half there, and now we're getting that mixing. But let's just see what happens if we now if we shut off the cold water, and we're going to see what happens there. I just want this to drop below 110, and that's actually I want it to get down to 107, because 107 is literally what we were getting for most of the time, even though the top was at 110, 111 when we didn't have the cold water and we just used after 1 day of sunlight. Mostly what we were getting out was 107 coming out of there, and then as the top part got low enough, it would jump up to 109 or 110. So I'm going to let this go to 107. Now, of course, you're not going to burn your hand putting it under there, not at 109. Now it's at 108. So we're very close to the temperature that we used to get without turning on the cold water. It jumps up to 109. 108. And this is holding up pretty well. After it was a huge rainstorm last night, and I don't see evidence of water having gotten in. Okay, we're at 107 now. That's an indication that we need to now turn up the cold water. But I was just observing, no rain got in there. A little bit of condensation has gotten in, but not a terrible amount. So this 3M tape does seem to seal pretty well. We'll have to repair it up like here. There might be spots where water could get in, and then they would corrode the pipes. Okay, now we're 107, 106. So now it is time to turn the cold water off. So the cold water gets turned off here. There we go. Now that I'm turning off the cold water, so it just got down to 107, which is what we were getting when we had the cold water off with a single day's sunlight. And now watch what happens. It's at 107 now, but there's no longer any cold water going down mixing with it. My suspicion is it's going to jump. Yep, went up to 108. Just as I predicted, that hot water is still hot. That's that top layer of water which just descended. Now it's up to 109. It'll probably get all the way up to 123 because we never used that top layer of hot water. We'll see. 109. Can you understand what I'm saying about the theory? There's hot water that was sitting at the very top, and hot water always rises, and so you get this thermocline. And then as we opened the valve, the water was slowly coming down, and of course the coolest water is down at the bottom, and over that valve there was water that was about 120, 121, 122. That we used up first, and we were getting down toward the hottest water, but then the float valve opened up and let cold water in down the pipe, which was pushing the water back up, but it was also mixing, so we started getting some lower temperatures. But now that we've shut off the cold water supply, the top layer is still coming down, and as you can see, that's the hottest, and so it's rising. It went from now 107, it went to 112. Depends on how much mixing there was. 113. Now it's draining. Now there's nothing else pushing from the bottom, so just the hot water is falling out. And that, think of it like a layer cake. There's still a layer of hot water. Now it's at 114, right? So think of it like
Just a second.
oh, yeah, the fertilizer hose. So there's a layer, think of it as there was a layer of 124 degree water, a layer of 123, 122, 131, 120, and then down here it was like 100, 111, 110, 109, all the way down to 96 at the bottom. But that top layer is just shifting down. So my
And there's nothing replacing it.
right, there's nothing replacing it but air because it's not a sealed barrel.
It does not feel from yet. We don't feel it from
No, we fill it, well, it goes in the top and then it goes down to the bottom. So we have to insulate the pipe inside while cold goes down that column of the pipe. But now we're back up to burning temperatures, got up to 117. So we've never now dipped below 107, and you can put your hand in there, I mean, that's still burning temperature. And we're going on 21 minutes, right?
Yeah, it's not the same as
Well, it's about 3 degrees shy. Now it's 118.
my cup of
Ooh, Penny.
either.
118, 117. I think we've reached, now it's dancing between 118, 117. I think because of the mixing, we've reached the top level of hot water. It is unlikely it's going to go any higher than that, unless the very top layer of the layer cake is higher than 118. But that's nice and warm. I mean, that's really good for, ow, 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 ow. That is hot.
But it's not as, yeah, you're right. It's start going down right now.
Yeah.
How do you know that?
I've watched it for days. I spent a lot of time out here doing live YouTube videos, and I now can measure the temperature. So for those of you just joining us, we have been, for the last 22 minutes, we've been monitoring the hot water output. Oh, look, it went to 119. So we are getting to that little layer of really hot water at the top of that burning layer. Yeah. I would suspect that since it was 124, this has got to, for that last layer, it's got to get up to 122 at least. I just want to squeeze a couple more degrees. See, 120, it's about to go to 120. So I think this is very successful. I think what we've demonstrated today is that a single handmade solar panel of 2 foot by 4 foot with 12 copper pipes, 5 foot length, on galvanized sheet, sort of battened down onto the galvanized sheet, is enough to do heat transfer with plexiglass, the thinnest piece of Lexan, a 2 foot by 4 foot piece for $33, so about $66 in Lexan, UV protected, non-yellowing, unbreakable, warranted plexiglass, which is pretty flexible, using 3M tape to bind it to a 1x4 and a 1x4 with a 2x4 and a 2x4 and some foam insulation in the back with some galvanized roofing material holding the foam insulation so a single person can carry the panel as I did, and a barrel, an open barrel with a screw lid with styrofoam and insulation around it, and a toilet float valve at the top gives you over 2 days of sunlight, gives you up to 124 at the very top, 119, but very hot water, which is useful for doing babies' cloth diapers if you, like us, do not want to ever use plastic diapers, because we don't want anything to go to landfill. Now it's at 120. If you'd hold the camera for 1 second, actually I'm going to climb up there. I want to show the toilet float valve. But hold that for a moment. Let me jump back up here. See how we're at 120? That's pretty good. So it's now beginning to trickle down. We're getting close to the end of this. I'll open this up. Let me have that. So you can see there's the toilet float valve. It is now down low enough so it would be in the open position, but there's plenty of hot water. Ooh, owie, ooh. Yeah, so ouch, it does burn. That's where it's coming out. So there's a good, let's see, my finger and my thumb there's that much water still in there, so about 6 inches. There, you can see it right there. And the hottest water is on top. So you can see the float valve comes in here and then brings the cold water in when and brings it to the bottom when we have that turned on. But we've shown that it's most efficient to use up the hottest water and then add the cold water up in there. That's part of what this experiment is for. Now it's dropped back down to 119. But you know, it's been on for almost a half an hour and there's still plenty of hot water in there coming out. And the nice thing is that you don't have to get a pressure sealed barrel. This is what we discovered in Cairo, Egypt when we started Solar Cities back in 2004, when we were building with Mustafa Darsh Hussein and with Hana Fathi and with the crew out there, with Musa and Sabah and Hella and Miriam and the crew from Wadi Environmental Science Center. So yeah, you can use one of these float valves, bring your cold water supply in there and have it go down to the bottom to push it up. And then you just insulate to hold the heat in and you get marvelous results. So we're still at 119 there. I guess for now I should let air in while this is draining out. I wonder what would happen, like if I seal it. There's no vacuum here. So let me climb down here very gingerly. Now it's at 120 again. And the reason it goes up is because, as I keep saying, the hottest water is always at the top. It's like a layer cake. So yeah, it's really good for washing those baby diapers. So now we're going on 27 minutes, but we started draining the water out at about 4 minutes in. So really we're at about 23 minutes of this water temperature. Certainly enough to do a couple runs of laundry and take some showers. And just wait till we get the second panel up this weekend. That's going to make it so that we get these results in 1 day instead of 2. And that is the goal. And I like using the IBC Tank biodigester as the stand for all of this, because you're doubling. You're getting solar hot water and biodigester. Now this is the gas holder. That's the actual digester. We could have put it on top of the digester and we could be running hot water in the mouth, in the feed pipe of the biodigester to help improve gas production. But the geometry of it now, the way we have it set, there's no room for it. But I think I'm going to run a pipe, actually a T, so that I can get hot water in the digester as well as into the shed for the laundry. And we're now at 117, 118 as you can see. Just waiting for it to stop. I just want to see what the last layer is. Now it got up to 119, right? It's got to be the very end of it's got to be 120. I would really be surprised if we don't see 120 at the last moment there. But we were about 6 inches from the bottom. So there's going to be plenty of hot water. This is an absolute success. I love the new design. When you do the design, of course, you take 2 pieces of Lexan and you have them cut. They always come in 2-foot lengths this way, but you cut the top and the bottom and you end up with 2 sections here and a little bit of overage down there. And then use the 3M tape to bind it together. We put a piece of board here to hold, and you have 2 sections, and that's about it. And you put some reflective styrofoam. Still, there's a little bit of condensation down there, so I want to make sure that the top is completely sealed because of that big rain we had yesterday. And we're getting down to the dregs now. We're at 119. So just finishing this up here. But yeah, biodigester and solar hot water as one unit and you don't need to build any infrastructure. The IBC tank is so useful for this. And then any overage we're getting is producing fertilizer in there. So yeah, you get hot water for your biodigester, and hot water for your shower, and hot water for your baby diaper washing machine. And but do invest in 2 panels. One is great if you have 2 days of continuous sunshine, but if you don't, then you might be short a little bit of hot water. So there we go. Still waiting. We're at 30 minutes, so that's about 26 minutes of hot water that we've seen. It never dipped below 106, got to 107, then we turned off the cold water coming in, and that's why we're able to double the length of time that we had from when we were using it with 1 day's sunshine. So that's pretty cool. All right, seems like we're getting to the end here. I should probably use this time to start grinding some food waste and then finish it up so we can feed the biodigester. Yeah, not quite done yet. I want to grind up the food waste for one thing. Yeah. Wait a minute, I think I hear the end of that. Still coming out, but much more of a trickle now. It seems like it's almost done, but the last dregs of hot water are at 119. So let me grind up the food waste as part of my chores. Isn't it? I mean, I'm right here and I got all this food waste that needs to be ground. Just take a second. I'm still experimenting. So let's turn this on. Another thing you need to know is that you can just spill food waste on the ground if it's ground up, and it won't attract any vermin at all. So you don't have to really collect it in a bucket, but we do because we want to feed the biodigester. So we grind this up, and in the meanwhile, we're still spilling out of the hot water system, and we're still on the solar hot water system. We're still coming out at 119 Fahrenheit, but it's coming to a trickle. So in a moment, I'm going to turn on the cold water and fill it back up. Meanwhile, I have this ground up food waste to go into, into the biodigester, and let me continue grinding up food waste. You see all those little roaches running around? They're only there because the food is not ground up. Once it's ground up, roaches are not interested, nor are flies, nor are rats. So grinding is critical. Once again, as I said, you can let this just spill on the ground because nothing will be interested in it. Let me pour this in a moment. There we go. And you can see it's a big old sloppy mess, but I don't mind. I'm holding the camera, so I can't do that very well. But the point is that ground up like this, it doesn't attract any vermin at all. And we know that from months and months of experience. So let me plug this unplug that, put this back. Yeah, so all in a day's labor. So the point is that if you just grind up your food waste and you just pour it on the garden like that, it will never attract roaches or flies. It won't create any odors. It won't attract feral cats. The chickens aren't interested in it. You can just let it spill in the garden, ground up food waste, and it'll turn into soil in 3 to 6 days. We tend to feed ours to the biodigester, and it's a bit messy right now, but we'll clean that up. And that way we get some methane to do our cooking on. And there you can see, to improve performance, we can have hot water